Thermodynamic process. So what is thermodynamic process? It is the process which brings change in the state of the system. Operation which brings change in the state of the system and state of the system can be expressed in different parameters like pressure P, then temperature T, volume V and internal energy U. Okay. So, if any two parameters are fixed, then third one will be automatically fixed according to the ideal gas equation PV equal RT. So, any of these parameters are fixed, then third will be automatically fixed. Okay. Now, state of the system can be changed by different processes. Now, let us discuss different processes. First one, isothermal process. Isothermal process. What is isothermal process? Process in which temperature of the system remains constant during the change of the system. During the change in the state of the system. So, during the change in the state of the system, temperature remains constant. Okay. So, process in which temperature remains constant. This process is called as isothermal process, and in such a process we can write dT, change in temperature, will be equal to 0. Okay, so in such a process the system can exchange heat but the temperature remains constant. Okay, the system may exchange heat with the surroundings by keeping temperature constant. Okay, this is called as isothermal process. Next process, second process is adiabatic process. In this process, the system does not exchange any heat with the surroundings. Okay, process in which system does not exchange heat with the surroundings. Okay, so this process is called as adiabatic process, which means no heat enters or leaves the system. Okay, no heat enters or leave the system, and we can write dq. Q represents heat. Change in heat will be equal to 0. There is no heat enters or leaves the system. Okay. But here in this case the temperature may change in this process. Example, process in a perfectly insulated vessel. Process in a perfectly insulated vessel. Okay. Next, third process, isobaric process. Isobaric process. Process in which what happens? Pressure of the system remains constant. Okay. Process in which pressure of the system remains constant. So next process, isochoric process. Process in which volume of the system remains constant. Volume of the system remains constant, that is dV is equal to 0. Next, reversible process. What is reversible process? Process is said to be reversible when energy change in each step of the process can be reversed by changing variables like pressure, volume and temperature acting on it. And this process is taking place infinitesimally slowly. Okay. So, process in which the energy change in each step is reversed by changing variables like pressure, temperature and volume acting on it. Okay. And this process is taking place infinitesimally slowly. Okay. That means the system is in thermodynamic equilibrium with the surroundings. The system is in thermodynamic equilibrium with the surroundings. Okay. Next process, irreversible process. Next process is irreversible process. Process which cannot be reversed by a small change in any of these controlling properties. Okay. Process cannot be reversed by a small change in any of these controlling properties. So, this process is taking place in one direction. Okay, takes place in one direction. Okay, and it does not remain equilibrium. Okay, does not remain equilibrium. But does not mean that the system cannot be restored to the original state. Now, next process is cyclic process. Cyclic process. So, now what is cyclic process? Process taking place in closed loop, which means initial and final state are identical. Okay. Process in closed loop. Such processes are called as cyclic process, and in this case the initial state and final state are identical. Okay, see the graph, pressure, volume. Okay. This is the initial state. Okay, A, B, C, D. Okay, A, B, C, D. So this process, the process taking place in this closed loop is called as cyclic process. Okay, so A to B. A to B. This change is called as isobaric expansion. isobaric expansion. Expansion takes place, okay, volume increases from A to B. Okay, so the pressure remains constant. So it is isobaric expansion. Next, B to C. B to C is isothermal expansion. Isothermal expansion. Okay. That is, from B to C there is a small change in the volume. So expansion takes place but the temperature remains constant. Pressure reduces. Okay, from B to C pressure decreases. Next, C to D. C to D. C to D is isobaric compression. Isobaric compression. Okay, pressure remains constant but change in volume decreases. So isobaric compression. What about D to A? D to A is isothermal compression. Okay, isothermal compression. Isothermal compression. There is a small change in the volume. So compression takes place, the temperature remains constant. The volume, the pressure also changes. So it is isothermal compression, and this process is called as cyclic process. In this case, the initial and final states are identical. Okay.